Hello everybody, I hope you're doing well. I myself am fine. I'm feeling ready to go on a brand new set of contest question videos. So I thought I'd start off with the 2000 Fermat papers. That's the grade 11 multiple choice contest, not to be confused with the Pascal or the Cayley, which are the grade 9 and grade 10 contests. And of course not to be confused with the Hypatia, which is the grade 11 level contest put out by Waterloo, but it's the written style contest. The Fermat is going to be multiple choice. So how about we take a look at this 2000 Fermat paper. Hopefully you've had a chance to try it for yourself. If you haven't, of course, there's a link in the description. So as with most of the multiple choice, actually all of the multiple choice contests, we're going to have only 1 hour to do this. We're going to be allowed calculators, and there's going to be 5 potential answers to each question. One of the things to keep in mind if you are doing this contest in real life is that if you leave a question unanswered, you get 2 marks, as opposed to an incorrect answer, which gets 0 marks, or a correct answer in part A gets 5. The incorrect answer in part B gets 6 marks, and for the really hard questions in part C, you get 8 marks if you're correct. But as I say, if you leave a question blank, if you admit that you just can't get an answer, you can get 2 marks for a maximum of 20 marks. Alright, so question number 1 on the 2000 Fermat paper. The sum of 29, 12, 23 is equal to, and then we have a bunch of options here. None of them are expressed as a single number. So we could take out our calculator and we could figure out the answer to 29 plus 12 plus 23, which I believe is 64. So we could do that, but we don't know which of these answers is correct because we don't know which one is actually equal to the expression of 64. So we have 6 squared, 4 to the power of 4, 8 to the power of 8, 64 to the power of 0, and 2 to the power of 6. So we need to find out which one of these gives us 64, which is what this sum is equal to. So, what have we got? We've got 6 squared, 4 to the 4, I think it was 8 to the 8, 64 to the 0, and 2 to the 6. Now I've done a lot of powers of 2, and if you've done any computer programming, you probably know some powers of 2 as well. You can know that 2 to the 6 is 64, and this will be the answer that we want. So if that jumps out at you off the page, if you just know your powers of 2, or if you know all the expressions for 64, don't worry about what I'm doing. Don't worry about working it out. If you've got the answer and you're confident in it, bubble it and move on. But if we were unsure, what we would do is we would get out our calculator and we'd calculate each of these. So 6 squared, why that's 36. And 4 to the power of 4, well that's 256. It's the same as 2 to the power of 8. 8 to the power of 8, that's going to be a bigger number. That's another rather large power of 2. It's 167777216 according to my calculator. So that's certainly way off. Remember, we're looking for 64. 64 to the power of 0, you could do that on your calculator, and you'll get out 1. But hopefully by now you know you've done enough exponents to know that any positive number to the power of 0 is always going to be 1. And as I said before, 2 to the 6, that's going to be 64. That's the one we want. So E will be our final answer. Okay. So I like this type of question where the question was straightforward, but the answers were sort of jumbled up and mysterious, and we had to do calculations on the answers rather than a calculation for the question. It's a nice little twist on the formula. And it's good to get us moving and actually thinking critically about the problems right from the get-go. So that's question number 1. And it's a nice little question. Hopefully this will all turn out to be a nice, good, clean contest. So we'll have to see by taking a look at some of the other questions. Question number 2 coming up in the next video.